All right, so we have Jake Kushner from South Fork Natural History Museum going to give a talk on tiger salamanders and his interesting radio telemetry work. Thanks.
Good afternoon, everyone. So I'm here to speak on some ongoing work with the South Fork Natural History Museum, tracking eastern tiger salamanders in the Long Pond Greenbelt. So in 2023, the South Fork Natural History Museum in Bridgehampton received a grant from the Holloman Price Foundation to conduct a study tracking the movements of eastern tiger salamanders around their breeding pools in the Long Pond Greenbelt. The study is designed to determine the extent of their movements from these pools and the upland habitat that they're using around them. They are a state endangered species, so this information is a really important aspect of their conservation. So the Long Pond Greenbelt is the study area. It's an ecologically significant system. It's over 1,900 acres. It has forests, fields, and a collection of coastal plain ponds, 13. And it's considered one of the most biodiverse ecosystems in New York. It harbors a variety of rare and imperiled species, including our eastern tiger salamander. So the eastern tiger salamander itself is a fossorial species, meaning they spend most of their time tucked away underground. Some studies have suggested up to 97% of the year tucked away underground. They have a really large, robust body. They can be up to 12 inches in length. They're considered one of the largest land-dwelling salamanders in the US. We generally see them in the 8-inch range during our field work. So they're a really unique species. So during the breeding season, they emerge from upland burrows, migrating to both permanent ponds and seasonal pools known as vernal pools, which are very delicate, we've heard about earlier today. And this is where they complete their breeding cycle. They lay gelatinous egg masses attached to the sticks and twigs lining the pond. Larvae hatch after several weeks, breathing through external gills, as you can see up here. Later in the summer, they're going to metamorphosize, leave these vernal pools, and travel into the upland habitat surrounding these pools. And this is where we don't really know where they're going, what kind of habitat they're using, or how far here. So we spoke a lot about vernal pools today. They're seasonal wetlands. They're characterized by periods of drying. Each spring, they're filled by heavy rains and snowmelt. They actually dry up by the end of the year. Because of this, it prevents the establishment of fish, which are voracious predators of amphibian eggs. So they're usually small. They usually lack an inlet and outlet. They have no connection to the water table. They're generally found in forested areas. And these are one of the type of pools that our tiger salamanders do use for breeding. They're also used by species known as obligate vernal pool species. They require vernal pools to breed, things like our spotted salamanders and our fairy shrimp. It's also important, again, to our tiger salamanders and other non-obligate species, like even green frogs. So even though they're temporary, they still provide that critical breeding habitat. So our research question: given their fossorial lifestyle, little is known about their upland habitat use. Where do they go once they leave these breeding pools? They're not easily observed given their fossorial lifestyle. They're tucked away in tunnels, burrows, root systems, so they're really not easily observed. So we're looking to answer a couple questions here. What distance are the tiger salamanders moving from their breeding pools? And then what upland habitat types are they using once they leave these pools? So the research technique here is really interesting. So we're using radio telemetry. They're a difficult species, again, given their fossorial nature. So radio telemetry is a really commonly used technique. It can be used to track animals as small as insects to larger megafauna as well. So it uses radio signals so we can track animals that are not readily observable. So we have a couple really critical pieces of equipment that we use. First is our radio receiver. In this study, we used the R410 from Advanced Telemetry Systems. I think of this like the radio receiver in your car. We can tune between different stations. Then we have our Yagi antenna, which you can see in the bottom corner. The more elements it has, the more horizontal bars, the more sensitive it is. This is like our antenna on our car. Helps us to pick up signal, and it's directional. We can figure out where the signal's coming from. And then you have your tags. So we used, also from Advanced Telemetry Systems, the R1645. It's a crystal-controlled two-stage implant transmitter. So they're only 0.9 grams. They're 2 centimeters at most, very small, and they run on a silver oxide battery like used in some watches, things like that. It has a 135-day battery life, so we're able to get a large part of their, the season that they're actually active. As they get into the summer, it gets hot and they're not quite as active. So we used a really thin, flexible wire because this is an implant transmitter, and we cut down the wire to fit the body cavity of the animal, so they're different depending on the size. And then we use the 144 to 151 megahertz frequency range, so all our tags produce a frequency within that range. Our detection range has really varied. It's attenuated as individuals move deeper underground, and it's blocked, by physical barriers. But we've been able to pick up signals 150 meters pretty readily, which is a great distance for an animal of this size. They don't have, they don't have great mobility, so that's really a good range for the amount of distance these salamanders might move. So we used two different methods to capture the salamanders. One was simply a dip net. As they're in their breeding pools at night, they're observable with flashlights and spotlights. We use dip nets to scoop them up. The other really interesting method we used was these funnel-style mesh minnow traps you could see up here. So we placed these in areas of the pond, especially around the edges, where vegetation really concentrated the movement of these salamanders. Some studies have used bait in the form of glow sticks, green and orange. We tried that. We did catch animals that way. I can't say whether it impacted our capture rate or not, but we were really successful with these mesh minnow traps. We'd catch multiple individuals in these traps. And then next is the surgical implantation technique. So again, they're underground most of the time, so external tag attachment is not feasible here. That's used on a lot of animals like lizards, but we can't do it here. As they burrow, it would rip off. So we emulated a technique first published in 2018, so it's still relatively new. This technique was first published by DeVries and Bartlett. So we anesthetize them using MS-222. It's really common in the fisheries world. It's an anesthetic. We make a small 1 to 2 centimeter incision in the pelvic region, offset of the parallel line of the body. The transmitters are inserted into the body cavity, and then we close them with sterile sutures. They're a really small suture. It was a lot of fun learning to use those. The salamanders then are held for 5 days post-surgery. We treat them with antibiotics, and we monitor them for successful signs of healing before release. They're all extremely active at the time of release. They all show major signs of healing. Their healing ability is pretty incredible. And those transmitters are, just so you know, are limited to 5% of the individual's body weight, of the total body weight. We capture pretty good-sized salamanders, so most of the time it's well under 3%. So then our actual tracking methodology. Upon release, we tracked these and located these individuals at least twice weekly, just using a handheld GPS unit. We then upload them to a GIS system. After data collection, we'll be able to look at home ranges, total movement, and core use areas as well. So we've had 2 field seasons under our belt now. Our first field season began in 2023, the breeding season, February to March or so. We captured 10 male tiger salamanders from 2 different breeding pools within the study area. Pool 1 is a small pool that's sort of vernal in nature. It reaches 3.5 feet in depth during peak inundation when it has the most water. It exhibits those periods of drying. It was a man-made pool, but it is readily used by these salamanders. And the surrounding habitat is dominated by thickets of high bush blueberry and multiflora rose before it goes out into a field ecosystem. So you can see the picture of the pond there, some high bush blueberry, and then the pond when it's dry here as well, completely dry. Fish are not able to establish themselves here. So the second pool is a permanent pond. It reaches depths of over 10 feet during peak inundation. Even though it's permanent, it is fishless. It was used as an irrigation pond for the field that it's in. The field was once cultivated. And it's located in the middle of this large field. The area surrounding it is generally open. There's no forest. There's very little shrub cover aside from 5 to 6 large high bush blueberry shrubs surrounding that area. And this is the pond here, frozen now, but they'll work their way into this pond as soon as the first edge thaws. You can see the surrounding area is very open aside from those couple large shrubs here. During the 2024 field season, we captured another 10 males, this time from 3 breeding pools, the first 2 that we originally captured animals from, and then a third pool. It's a true vernal pool. It's really rarely reaches depths of more than 2 feet, and this is right on the transition between the field and forest habitat, a little bit more usual for salamander, eastern tiger salamander habitat. It's surrounded by a deciduous oak-dominated forest. The understory there is rather open. There's some large thickets of invasives like multiflora rose. And the area directly surrounding the pond, again, is just a couple high bush blueberry. There's some winterberry, some common wetland plants of the area. So you can just see some of the surrounding plants here, a couple shrubs, the forest in the background. Then the upland habitat, this is the bulk of the study area is just an open field. It has broom sedge, little bluestem, and switchgrass. It has very little shrub cover and no forest cover. It's a very open, dry area. You can see some examples here. Again, just grasses, very little shrub cover, forest way out in the background there. Just see an example of how open it is here. So data collection is still ongoing, but we've made a couple initial observations. Many of these salamanders use burrows extremely close to the pond edge, within 5 meters. So there were those large rounded root systems of the high bush blueberry. It appears to be some of their preferred habitat, which is not unusual for these guys. The root systems are like multi-tiered, and we found that several individuals will use those same root systems. So there's likely reasons for this. Limiting the distance needed to reach that pool upon migration is going to limit the ability for a predator or for desiccation. When they migrate, they're the most vulnerable. There's quite a few predators in this area, like snakes, birds, mesopredators like raccoons. So an increased distance is an increased risk of predation. Again, male tiger salamanders generally outnumber females, so there's some competition for breeding. If they're closer to the pool, they're able to return to the pool first, stage themselves for that first arriving female, or to beat out other competing males. We also noticed they used burrows on the edge of a planted pine grove. They liked the root systems of some of the bushes growing there. So that was another kind of preferred habitat there. So we also had some really kind of surprising observations. So a lot of the individuals remained pretty close to the pond, as I mentioned before, but we had a couple larger scale movements. These movements were triggered by heavy precipitation events. Otherwise, movement between burrows was pretty rare. The largest of our excursions was 130 meters from the breeding pool. So that's pretty large for an animal of this size. But other studies have documented movements of almost 260 meters. So pretty substantially smaller movements than what's been documented. But the individuals who made these larger excursions settled in burrows and root systems and small mammal burrow systems within upland field habitat. There's really no overhead cover. The dominant cover is just grass. There's no leaf litter, and again, no overhead canopy. We tracked one, too, to the edge of a residential home. So these areas are pretty odd areas for eastern tiger salamander to take cover. There's a lot of predators in these areas. And again, a larger distance to move to the pond in an open area like that leaves them vulnerable to predation from things like black racers, which there are a large population in that area, as well as amphibian-eating birds like herons and our raccoons. So we're not quite sure why these animals are using these areas, so I'm looking forward to another field season here to hopefully figure out what they're doing in these areas. So we have one left to conduct here. Normally, I'd be out capturing salamanders at this time of the year. The snow and this winter has really thrown me off, so still waiting. The ponds that these salamanders generally use are dry, so we'll see what's to come. So this is just an example of those areas. So I'm standing directly above their burrows here. You can see it's really wide open. There's no cover to keep them safe here. It's really vulnerable to desiccation here. This area gets full sun. And these areas are used really extensively by black racers, which are predators of amphibians, and things like birds as well. So thank you to the Holloman Price Foundation, and I'd be happy to answer any questions. Yes.
Is it
So yeah, we kept them to a really low percentage of their total body weight, hoping, to limit impacts of the transmitter on the animal. I thought with some of these movements, the burrows, they were really close to these wetlands the snakes use as well. So at first I thought a lot of my data here might be a result of predation. Salamanders are eaten a lot, but I was actually able to, ground truth many of these salamanders. So I was able to see them, physically observe them in these burrows and in these areas. So I know they weren't moved there by predation. But yeah, I'm not sure about the limited distances. I think if they reach good habitat close by, why go any further? It just opens them up to predation and desiccation. So I think they hit that good habitat close by and just kind of stuck in there.
Have you thought of reporting them pre-op and post-op just to compare to see if the surgical procedure is responsible?
Well, we can't monitor their movements really, pre-surgery, but body condition remains really, really good after surgery. They seem to heal really well.
Any reason why you didn't catch any females?
So we actually did catch females, but we were not permitted, to track them. They're very sensitive during this time of the year. It's their breeding system. But I'd say for every 5 males, we caught 1 female or so.
Did you find any other salamander species?
So in one of the pools, they do breed. It overlaps with some spotted salamanders and wood frogs as well, that true vernal pool. Yes.
Where do you implant the tag on the salamander, and is there like a minimum size we can start tagging at?
Yeah, so that 5% of the body weight, but we kept it to really 3% for our study. So they have to be large enough that the transmitter's not going to weigh more than 3%, and it goes in the abdomen, in the pelvic region, right above the pelvis, sort of off from the midline of the body in that lower kind of stomach cavity area.
Do you go off of weight versus length?
Yeah, generally weight. They all kind of are around the same length, and they can really vary in weight. Yes.
You don't think you're tracking a salamander and you're actually tracking a black racer that ate a salamander?
Yeah, so that was one of my concerns, especially with those that settled out in the middle of the field there, where I tend to encounter black racers. So I did physically observe those salamanders to make sure. I did ground truth because that was one of my concerns, that it was a result of predation.
Were there a lot of recaptures from the first field season to the second?
I did see one that we caught previously, that I could tell. Aside from that, I either couldn't tell or didn't encounter any other individuals. Any other questions?
Great job, Chase. So based on that question, so the tags, because they only last like 130 days, so then the issue is that after the next year, if you can't tell the tag was implanted, you have no way of knowing if it was a recapture?
Yeah, so you can sort of tell from some of the pattern. I've been taking photos to try to get pattern, and I didn't notice any pattern that was the same. So I think, I don't think I had too many recaptures there, but you can sort of tell from pattern.
Are they magnetic, like the tags? Like, could you put a magnet against the abdomen and see?
So someone suggested using like a metal detector kind of thing. So that could be possible for sure.
Like, you wouldn't be able to ID the individual perfectly, maybe, but you'd still have like general recapture rates for like a abundance estimate.
That's a great thought. All right, thank you.